As we're working to solve these equations, remember we essentially always have two options, either to distribute first or to divide first. And you might instinctively just sort of have one method of distributing or dividing that makes it just feel easier for you. So personally, I tend to distribute first. My brain wants to go there first. But sometimes I'm faced with a situation where like distributing first might actually make things feel harder. And so when you think about which method you're choosing, things to look for are things that will help you use powers of 10, things that will help you eliminate fractions or decimals, because universally we're not very good at using fractions and decimals, and then moves that will result in whole numbers. And so, for example, in this one, my instinct right here first was to distribute this 2,000 in, but then I paused for a second and I thought, well, wait, 2,000 times a third, well, I can kind of figure that out, but that's harder for my brain. But maybe if I divide first, that's a lot easier, because now suddenly if I were to rewrite this one, 2,000 x minus 0.03 equals 6,000. If I simply divide by 2,000 first, well, anything divided by itself is 1, and so now I'm just left with x minus 0.03. Well, 6,000 divided by 2,000, I can cross out those zeros, and 6 divided by 2 is 3. And so now I'm simply left with, well, I can just add 0.03 to both sides and get x equals 3.03. So sometimes your instinct is wrong. Like my instinct was to distribute first, but then I started to, and that felt icky because I had to think of like, oh, this fraction and decimal, I didn't like it. So dividing first, because I looked for whole numbers, was really helpful. So looking, that was number 1. If I look at number 2, where I've got this 2 times the quantity x plus 1.25 equals 3.5, maybe I'm going to try the divide first, but then, oops, my lead is broken. 2 times x plus 1.25 equals 3.5. I would have to divide 3.5 by 2. I don't really want to do that in my brain, but it's a little bit easier for me to think about 2 times 1.5. And so if I distribute this in, I get 2x, because 2 times x is 2x. And then let's see here, 2 times 1.25, well, 2 times 0.25 is going to be a half, and then that would be 2 times 1 is 2.5. And so then I can just simply copy that down. Well, that's nice, because now when I go to subtract this, to do my inverse operations, maintain my property of equality, 2.5 minus 2.5, that disappears. 3.5 minus 2.5 is 1. And so now I get 2x equals 1, and so I know I need to divide both sides by 2, and so x equals 1/2. For this third one, let's see here, I've got this 1/4 times 4 plus x equals 4/3. So maybe I want to get rid of this fraction first. Oops, my parentheses should be there. There we go. That would be one option, because I generally hate fractions. But I also think that, well, 1/4 of 4, that's 1. So that maybe I might distribute it in first. And so I could simply write this as, well, 1/4 of 4 is 1 plus 1/4 x equals 4/3. And the reason I like this method is because I could really rewrite this 1 as 3/3. And the reason that's helpful is because in a minute here I'm going to need to subtract this 1 from this 4/3. And so if I subtract 3/3 from 3/3, that disappears, and so I'm left with 1/4 x equals, well, 4/3 minus 3/3 is simply 1/3. And now to get rid of my 1/4, I'm going to multiply by my reciprocal on both sides and get x equals 4/3. So there, what I noticed is I was able to result in a whole number and eliminate fractions and decimals. In this fourth one, now I have negative 10 times x minus 1.7 equals negative 3. I could divide first, but then I'm going to be left with this like 3/10, and I hate fractions. And interestingly, if I multiply this 10 in, I'm going to get negative 10x. And then let's see here, that's going to be, oh no, that's a negative 10 on the outside. Oh yeah, that's correct. So negative 10x. And then a negative 10 times a negative 1.7 is going to be plus 17. And then now I'm left with that negative 3. Well, that's nice because now I can simply subtract negative 17 from both sides. And 17 minus 7, or positive 17 minus 17 is 0. Negative 3 and negative 17 is negative 20. So I get negative 10x equals negative 20. And now I can simply divide both sides by negative 10 to get x equals a negative by a negative is a positive, and so that's going to be positive 2. And then let's see here, this last one, I have 5.4 equals 0.3 times x plus 8. So I'm like, ew, decimal, I don't like you. But maybe if I think for just a second, I could essentially multiply this whole thing by 10. If I multiply both sides by 10, then I can get rid of this decimal, right? If I multiply 5.4 times 10, that'll move my decimal place there. That'll move my decimal place there. Property of equality says that didn't really get me any closer, but it got rid of that decimal, which I didn't like. Now I want to divide both sides by 3, and 54 divided by 3, 3 goes into 5 once, and I'd have 2 left over. Oh, so that would be 18. And so now that 3 disappears, and so I'm left with x plus 8 on this side. So I can subtract 8 on either side. X equals 10. So key takeaways from this: when you are solving more complicated equations that involve either negative numbers or fractions, again, you're looking for the opportunity to either distribute first or divide first. And key things to look for are things that will help you use powers of 10, moves that will help eliminate fractions and decimals, and things that will result in whole numbers.